Good morning. Good afternoon. Welcome back for this topic. So I will focus on seamless integration to take Kubernetes into your existing monitoring stack. Here today, I will cover the following aspects. First of all, the background, why we have this scenario, and the generated problems in this scenario. So we have all these problems, how to solve all these problems, and then I will have a brief summarization for the application scenarios. So first of all, brief introduction, Ding Shaojun from IBM, and you can call me Iris. I use this topic to share with you because in the cloud team, we worked as the CTO team for the IBM Cloud for offering the solutions, and now I work for the open source lab of IBM and focused on service mesh. I also have lots of experience in terms of the development of middlewares. So first of all, let's have a look at the background of the related problems. As I mentioned before, in my previous department, which was a cloud CPU, we aim to provide the monitoring capability. When it comes to monitoring, well, this is actually a legacy problem. We have the IT system and the monitoring is necessary. You can imagine this. For any production system or any IT system, if you don't have monitoring, then this would be like a man without eyes. You don't know the current status of your system. This is very risky. And from my perspective, I think monitoring covers three key parts. One is the data collection, upfront data collection, operated in different virtual machines, and your workload. You need different agents to collect data. So this is the first core part. And second core part is for the collected data, you need to store the data. Your metrics need to have a place to store the data. So you have this collection of the data and storage of data. You want to apply this data. Based on the data you collected, you will have analysis. Or on the specifications, this will trigger alerts, or you have the dashboard to have the comprehensive demonstration to help you understand the current status of the system. So these three parts are core to the monitoring system, and this is the conventional monitoring system components. It has lots of agents, and these are the agents. And here, for each agent, it can send metrics to collector. The collector can publish metrics and store all the metrics in the data store, and the agents can retrieve data from the data agent and the data store, and then to send it to the dashboard. Now this is a perfect operation and very stable. But in recent several years, we have a very popular microservice or Kubernetes container and the orchestration. So our team wants to migrate its workload to some physical and virtual machines into the clusters. As you can see here, we have the workload of some of the teams have been migrated to this cluster. And after this migration, the monitoring will also have some changes. Some teams will naturally think that for this project, the native monitoring is Prometheus, and this team do not want to continue to use the conventional or the legacy monitoring, and they want to use the Prometheus. So they integrate Prometheus. Another issue is within our team, we have lots of the requests. We hope that for the metrics, we could have a central place for storage. We also have third-party monitoring solution. So in general, your scenario has lots of players, so this would be very complex. And our monitoring team has lots of pressure because of this. They don't know how to fit for these complex situations. because lots of legacy systems haven't got the migration. So how you can have the uniform orchestration plan for the legacy and the new systems. You have lots of senior level managers, and they hope to have a central place to log into the central place and to view the system status in general, and not like the Prometheus give them a dashboard and they can access the website to check the status.
Maybe we log in several places to see what it looks like. Everybody's crazy, and it feels is very complex. So we must know the background information. This is the background information. After getting to know the background and trouble, and let us have a look at the problems. So if you look at the machine, and we know that what problems we'll have. Number one, short-lived and there's long-running. Previously, if it is deployed well, you can just run it. But now you put it into the container and pod. But sometimes some containers can run several seconds and can just die away. So compared to the long-running metrics, how to differentiate these short-lived and long-running, how to monitor them is a big challenge. The second challenge will be the dynamic. And previously, the workload is running on the server, and we just need to monitor CPU and memory and disk. But now you find that due to the Kubernetes has its own functionality, maybe sometimes your pod is running on this pod, but up later it just moved to another node. So in this case, how do you monitor them? How to detect the problem? So this will be a challenge. The third challenge will be the microservices from a monolithic application to the microservices. So now when there is a request, it just go across several microservices like service A, B, and C. So how to detect the problems will be a challenge. But now you don't know which microservice has some problems, so you have to figure out the tracing between the different microservices to find what is going on. This will be the third challenge. The fourth challenge will be a large amount of metrics. Previously, you have your own applications, it is fine, but now you have to imagine that when the Kubernetes including played in this big arena, and for the host you need to moderate for the Kubernetes cluster and the relevant metrics and the pod data and the container data. All of this you have to detect and monitor all of them. So with this huge amount of data and the metrics, how to monitor them will be a challenge. Many teams use other monitoring solutions. After that, it is hard for them to get a central view of the whole system status. So based on all of these above-mentioned problems, our team has such a matrix integration architecture. If you look at the left-hand side, here are the previous or the traditional solutions, and in terms of Prometheus, we have the own adapter, and some team use a graphic, and while others use a CloudD, and there's a lot of other self-developed solutions. But within our team, if you're using the IBM Cloud, you know there are a lot of services. So we hope that each of them will have adapter, and the metrics can be matched with each adapter, so we can collect the metrics and do the format transformation. And we also have this a terminal system and end system. And sometimes we know some teams hope they can have a brand new solution. They can use the third-party monitoring services. So by doing this, we can integrate all of them. When there is a cloud monitoring service or the store, all of these can be integrated. It's like a human body structure. it's a integrative architecture. In terms of a Kubernetes, here are our solution. This is solution 1, and each server team has its own problems. Some of the teams work well with us, how they can maintain their traditional system. Maybe some of them are transferred to the Kubernetes. So in this case, they hope that can they maintain what it is. So in this case, we can help them reduce the workload. So our solution 1 will be the self-maintained. We call it the city monitor internally, and it's our solution. This is a structure graph. It relies on two things. It relies on KBS API server and will use the east and west functionality, so as to monitor the changes of clusters and can get the situation of the clusters. And by matching, it can get the C advisor and get the data of container. So there are two ways of deployment. One is regarded as the ordinary pod. The other is the outside of the cluster. By doing this, you can monitor multi-clusters. This is a Kubernetes client. It can monitor the resource changes of cluster and can get the situation of the clusters, and it can watch all of the problems internally. So we can take it as a metrics, and you can ask the customer command. So you see this task is complicated. Maybe let's say there's KB2. Maybe there are some monitor scripts running, and we can support them to run a script on the pod and can get relevant metrics. By doing this, we can get such a metrics to customize your own healthy cluster. So this is the solution. For the whole cluster, we know we can get the resource usage for the whole cluster. We will do the metric integration. We can get the demo container data. We do the categorization, and we know the situation of each pod. And for the class level and node level, we know all of the status quo. And we can, so that we can get resource usage for pod. We can know the resource usage for nodes. We can get the node status, pod status, node number, pod number, cluster events. Apart from monitoring the Kubernetes cluster, we can also monitor the Docker container. And so by doing this, they rely on C advisor to get the data of to get the data, on this node, the active container accounts, and the resource usage for whole containers on the host, and the CPU and the memory and disk, and all of these resources can be known. We give the solution to the servers team. We also find some problems. As you see on the structures graph, we overly rely on the C advisor on the bottom level. Maybe some teams said there is no the C advisor. They can do other trials. They can do a demo center. They can do the city level. They can deploy the C advisor. After we cooperate with the C advisor and we can get metrics with C advisor, we find that their pod has been opened. So in this case, the Kubernetes configuration must see some changes to support our solution. This is our solution 1, the dashboard. Actually, this is a screenshot of dashboard. You see here the cluster. This is cluster level. And this is a pod level and the pod status and the cluster and event. Here is the solution 2. A lot of teams think that all of the loads are on the Kubernetes, so they use Prometheus, but they find that there are a lot of pain points because Prometheus storage is a burden for them, and it's a little bit hard for them to maintain the Prometheus. So the old load is run and monitored in the old way. So after the introduction of Prometheus, how we can get a new solution? So in this case, we get the solution 2. We have the Prometheus adapter. We know that Prometheus has its own searching language. It's called the search language. So this Prom adapter executes the search language of Prometheus. And for the right hand, you can see that it is a code segment. This is a code sample. Maybe let's say this is a Prometheus URL, and here is the data we want to search. For the adapter, it helps us search the Prometheus based on your definition, and can get the result and send it on a webhook. And here is the structure, and it can transfer to the Kafka. And so by doing this, the Prometheus metrics can be integrated with our monitoring solution seamlessly. Some of the team will use their own alert, maybe while others don't use. It doesn't matter because our metrics is available here. We can use a previous alert system to do the current alert system. And we have our default. All of the Prometheus metrics can be used here. This is solution 3 related to Prometheus. Many teams find that the solution 2 is possible, but if the search matrix is numerous, the whole Prometheus will go crash because the Prometheus grasp data, and if the capability will be slowed down due to the frequent search. So the many teams have such complaints. Within the community, the Prometheus 1.9 version support the remote write. So for the remote write, its performance is pretty good. When it goes well with the Prometheus, it is a pull model instead of a push model. So like the Prometheus will connect with the targets and get the data and pull the data. But in terms of Prometheus, when it pull and it also push, so it will not occupy too much Prometheus capability and resources. So by doing this, we just come up with this good solution. But you have to change the configuration of the Prometheus to some degree. Here is a configuration file. You have to write a URL, and this is a webhook address. So by doing this, the metrics can be deployed, can be got in this way. So you see, by doing this, we can have a perfect solution 3. And there is another solution. It's called exporter only. Many teams transfer their load into the clusters, and they find you need to maintain the old monitoring scale, but the Prometheus they also need to maintain it, and so they have to maintain both systems. This is time-consuming, so why cannot they abandon the Prometheus system? But they also hope that the Prometheus monitoring is pretty good. They have invested a lot in this regard. Their service must have the exporter structure. But maybe if you go back to the old system, we welcome this approach. But how to reduce your cost, how to maintain your previous systems, how to cut the Prometheus but while maintaining your resources and your data. So here is our solution for. It's called exporter only. If the Prometheus is not available, but all of the metrics and the exporter can be maintained. So we write the Kubernetes controller. So this
controller can use the Listen Watch API to monitor deployed service changes. Then it will analyze the service. So this is the segment of the code, and I captured part of the code. Very easy logic. First of all, about controller, you can see here the Kubernetes controller. You will know how to write the controller. Then you get the controller, and you have your service. If this is the exporter, you should have a label and annotation. If you have this annotation, then based on the Prometheus io.pod and the address, you will get the address. So you can fill the targets dynamically, not statically. And if you have the service go down or go up, then I will have all this information. I also have these workers to retrieve the data from the targets, but also you need to transfer lots of formats. For example, for the label of Prometheus, you can transfer this into the desired format you need. This is Prometheus Dashboard display. The upper left corner applied the Prometheus searching method, and for this one, the lower one used the remote write. We captured this because I want to show you this solution to tell you that we can put this in our solution, but also publish it in the third-party solution. So this interface is a kind of a commercial solution, the pod dashboard. And you can see here there are lots of data. So the pod level, node level, and the container data are all stored here. A brief summary about pros and cons of different monitoring strategies and use cases. First of all, self-maintained. The pros are no extra maintenance effort. You can only rely on the resources that we offer you, so no extra cost for maintenance of Prometheus. But cons is you need self-development. The user case, as I mentioned before, small workload migrated to Kubernetes. If you want to use a legacy system, no Prometheus exists. So you can select this solution. And second solution is Prometheus with remote write. If your team has Prometheus, and if you select this solution, no impact on performance, but cons is you need to change the configuration because you need to enable the Prometheus. And in the remote write community, that was just stable, and now we think that it has been very stable. So lots of versions for Prometheus are very low, and we need to upgrade. And you also need to maintain your Prometheus, so generate cost. And use case relating to the Prometheus. And third solution is Prometheus with query. The cons include, in some scenarios, the team wants to take the key metrics out for long-term storage. As I mentioned before, for some metrics, they don't need to change, and they just need small or limited amount of the change, the metrics. and no significant impact for performance. But if you need to change the configuration, then this does not work for you. But its pro is this is transparent and no extra resources needed, and no need for the upgrade or update. So no need for maintenance effort. The last one is exporters only. So you can maintain your existing investment, no performance penalty and no maintenance effort. And we need to rely on the exporters and the writing for exporters, etc. If you are quite adapted to these methods, then you can select this. And for the exporters, we can help you. User cases include no Prometheus but with exporters. So these are the integration metrics. Lastly, let's see how alert has integration. Some teams within our team, the internal alert, as you know, if you do not have analysis or processing for alert, then your O&M team will have lots of pressure. In the morning session, we have learned a lot about how to operate alert and do not false alert. We have optimized. For example, we have a correlation engine. What does it mean? One alert, one time, someday, if you have 100 alerts and you can locate some analysis and you can find that all these are generated by one trouble, and you need to have the troubleshooting. And sometimes you also have the auto-healing alert. No need for manual work. You just need script or text to have the auto-healing through these engines, so they can enjoy all the benefits. So you have the alert generated infrastructure. The Prometheus alert also support webhook. So this is alert integration. We have webhook, alert tip. So consumers here, you can see the arrows here. This is a very large arrow. And through the event correlation, the auto-healing will be decreased, and then the alert sending engine will be decreased as well. So the script will be fixed, and we will resolve the problems, and no need for manual maintenance. So this is the alert integration, and we do like this, and very helpful results. And lastly, I'd like to show you a small demo about how to integrate the Prometheus data. I only have the old version, sorry. This has my colleague's portrait here. Zooming in. This is two adapter demos of Prometheus. This is the first one. We have our URL of Prometheus and integrate with third-party monitoring strategy and these are the metrics. After this, you can see here we have all these metrics. Also for the cluster level metrics, if the Prometheus want to search the cluster level data, then you need to have the aggregation. And this significantly impacts the performance. But here, you don't need to do this. And this part can help you to finish the aggregation and no significant performance impact. This is the pod data. Originally, this is 0, and the data transmission is very quick. This is the solution of remote write. This is the config script. My fellow speakers have shared with us about how to config this. This is Prometheus. So remote write can be enabled. Here you can add the parameters about the configs, but the core is if you fix the config of Prometheus. So these are the remote writes. If you activate this, you can have all data very quickly in the dashboard. So this is my report to share with you today. Any questions? Microphone, please. I cannot have direct access to the Prometheus, so you first of all need to deal with the connectivity, the internet. Any scenarios that assume you have the edge computing machine, you also need to collect the metrics. We haven't touched this part. Thank you. Any other questions? We now have this scenario. In Kubernetes, we have the deployment of Prometheus. Originally, we don't use a Kubernetes. We also have Prometheus for monitoring. Now we want to integrate the internal and external part. And now what we do is to use a federate Prometheus. But when we have lots of metrics, or when the internet goes through some problems, the external will pull the metrics. So we have lots of metrics, and sometimes we'll suffer from loss. So I'm thinking that just now you shared with us about the remote register, and I'm thinking that is it feasible for us to apply the remote write to achieve the internal Kubernetes Prometheus and the existing Prometheus integration. For remote write, you need to have the target address. You can change it into another export of Prometheus. I think in theory this is feasible. Thank you. Any other questions? Thank you. You mentioned about alert auto-resolve. What about the logic? How you realize this? After resolve, we'll send to Prometheus a new matrix to fix it, to resolve it. It's like the matrix come back to the normal state. If I don't tell it it can also detect that it has gone back to the normal state, right? Because it keeps collecting. Yes, after the self-healing, yes, its metrics will come back to normal. So what about the significance of auto-resolve? Why does it matter? Because metrics also has the latency or delay. We want to resolve it in time because of timing. So auto-resolve, how it judge you have finished the auto-healing. Not only in Prometheus, we have the alert engine. The Prometheus alert will not automatically be sent to our O&M staff. So it will have the auto-resolve in this engine. After healing, the metrics will be back to normal. Yes, it will automatically be resolved.
So you mainly focus on the integration, but actually the integration must be focused on the IBM's multiple system. Yes, our ultimate goal is to integrate all of the systems, but there's no limit about this. And it's not necessarily our own solution. Maybe you can use a third-party solution. We know some of our clients also use third-party solution. And I think that we just provide such a comprehensive integrated system. So you mean that this target system is not only limited to your IBM system? No, it isn't. Okay, that's all for my part. Thank you. Thank you for listening.